Hello, seventh grade. It is Wednesday, April 22nd, and we are continuing on with lesson 104. Now, tomorrow we are not ready yet to have a test, and so we will have lesson 104 due on Thursday. And then remember, Thursday will not be due till Monday because we're going to take a break on Fridays for people to catch up with their work. Okay, so lesson 104 covers three things: semicircles, arcs, and sectors. So let's first talk about a semicircle. Well, what is it? It's just half of a circle. That's all it is. And so let's look at this figure right here. We have a semicircle attached to three straight sides here. And so this is not a polygon. A polygon, all sides are segments. And so this has a curve. It's not a polygon, but it is a shape that we can find the perimeter of, and we can find the area. So let's go ahead and do that. Let's first find the perimeter. Well, let's go ahead and do the straight sides first. The perimeter for the straight sides, we've got a 6 here and a 6 here. So we're going to go ahead and put those there. We've got a 6, we've got a 6. Now, what is this length over here? It is not given to us. Well, it's not given to us directly, but if we look on this side, we see that the length over here we're looking for, the solid line, is the same measurement as the diameter of the semicircle. Well, the radius is 5, and so what would the diameter be? 5 times 2, it would be 10. So I'm going to put a 10 over here, and I'm going to put that up here. 10 is one of the three sides that we're going to use to find the perimeter. Now, I have some students who like to add this dash line to the perimeter. That is not part of the perimeter. The perimeter is like putting a fence around, if this were a yard, you're putting a fence around it. You would not include that dash line. That dash line is just there to show you that that would be the diameter of a circle. Okay, now the last thing we have to do is add in this arc length. We call this an arc because it's part of the circumference of the circle. We've talked about that before, what an arc is. Now, it is simply 1/2 of the circumference, is it not? Okay, so let's go ahead and find the arc length, and then we'll add it over here. Well, the arc length is going to be pi times the diameter, but then we're going to do what? We're going to divide it by 2 because this is half of the circumference. So let's go ahead and use pi as 3.14. We know my diameter is 5 times 2 is 10. And I'm going to divide that by 2 because it's just half of a circle, half of the circumference. And I'm going to go ahead and cancel here. 10 over 2 is 5 over 1. And so I've got 3.14, or pi times 5. Well, let's go ahead and calculate that. I'm going to have a 7 here, a 15, and a decimal point, 15.70. So I'm going to add that down here. 15.7. Now notice how I'm lining up my decimal point there. All of these are whole numbers, okay? So be careful. We're going to add all those together and find the complete perimeter. So I've got, these are all zeros, aren't they? And so I'm going to put a 0.7 there. I've got 6 plus 6 is 12, plus 5 is 17. Carry the 1, 1, 2, 3. I've got 37.7, and let's call the units centimeters. And so I found the perimeter by taking half of the circumference, pi d, divided by 2, and adding it to the other three straight sides. Now, let's go ahead and find the area of this shape, okay? Now, it's 2 parts, isn't it? The first part over here is a rectangle. And the rectangle's area is simply going to be 6 times 10. It is going to be 60. So I'm going to put that part right here. And what we're going to have to do is add to it the area of this semicircle. Well, let's go ahead over here. Well, let's go over here. Let's find the area of the semicircle. What is it? It's simply pi times r squared. What? Divided by 2, because it is half of a circle. So it's the formula you know, pi r squared, but divided by 2. So let's go ahead and take pi, 3.14. And what is my radius? It is 5. I'm going to square that to 25, and I'm going to divide by 2. Well, I've got kind of a sad thing here in that 25 divided by 2, that doesn't cancel out. I could go ahead and divide pi by 2 if I wanted to, but that's not very easy, is it? So what I'm going to go ahead and do for my area is I'm going to go ahead and multiply. Do I have more room over here? Let's do that. I'm going to multiply pi times 25. Let's go ahead and do that, pi r squared, and then we'll divide it by 2. Okay, so I've got a 20, I've got a 7, I've got a 15. I'm going to double pi to 628, a 0, a 15, 5, 6, 7, 8, 6, 7. Okay, 2 decimal places. So I have 78.5 is the area of the semicircle. Pi r squared divided by 2. Wait, oh, I didn't divide by 2. Oh my goodness gracious. See, this is so good. I'm going to leave my mistake on there so you can see it and you can remember. All right. So I've got to now divide 2 into 78.5. Okay. Always remember that. It's half of a circle. Okay. So 2 goes into 7 3 times. 9.5. That's going to be a 50. I'm getting 39.25. All righty, now notice I lined up my decimal points here. I have pi r squared divided by 2. Whoa, almost forgot it. Now let's go ahead and add that together. I've got a 0.25, a 9, and a 9. And so my answer is 99.25. Let me erase this so we can see what we got here. 99.25, and that is centimeters squared. All right, pi r squared divided by 2 plus the area of the rectangle. Rectangle plus pi r squared divided by 2. All right, now let's go over here and talk about major and minor arcs. Okay, I've got a big circle. It's a terrible circle. It's a lumpy circle, but please forgive. All right, now I've got 3 points in the circle, point A, B, C. Now, what is minor arc AB? Notice we can put the arc right here, the little symbol AB there. Now, minor arc AB. Now, I can think of arc AB as this short distance between A and B. Or I could think of it as from A to B all the way around through C. Okay, now, which one is the minor arc? It's the smaller one, less than 180 degrees. Okay, so less than a semicircle's arc. So here, this is my minor arc AB. A major arc, we're going to use 3 letters for, because this major arc is I wish I had a colored pen, CB. Okay, you see that? My major arc is ACB. It starts at A, it goes through C, and then ends up at B. So my major arc is greater than 180 degrees. It's greater than half the circle, and a minor arc is going to be less than half of the circle's circumference. Okay? Now, let's go to the second page, and then or side, and we're going to do a couple more things, and then we're going to do some homework problems. Now, the other thing we want to talk about, let's slide this over, is sectors and arcs. Okay, what is a sector? We talked about a sector when we talked about investigation on circles. It's like a piece of pie. It's a piece of pie. And here is my circle. I've got it dotted. This is a little bit more decent circle. Thank you. And here is my sector. Now, I notice that my sector's central angle, vertex at the center, is 60 degrees. And I've got a radius of 6 centimeters. And the first thing we're going to do is find the length of the arc of this sector. Now, remember, an arc is just part of the circumference. Okay. What fraction of the whole circumference is that little arc? Well, let's first write the formula for the circumference of a circle. We know it is pi d. Now, pi d would be all the way around, but we just want this fraction of the whole circumference. And the way I decide what the fraction is I look at the central angle. This is a 60-degree angle. All the way around would be 360. So there is my fraction. My fraction is 60, the angle, over a complete circle, 360. So it's 60 3/60ths of pi d. And let's go ahead and fill in the rest of our information here. And I'm going to go ahead and reduce this. Well, what does this reduce to? 6/36, after I cancel out my tens, is 1/6. And so that arc is 1/6 of the complete circumference. Now, we're going to go ahead and use, what are we going to use for pi? Let's use 3.14. And what is my diameter? Careful, the radius is 6, double it, the diameter is 12. Now what's really nice here, I can cancel out 12/1 and 1/6. That's going to cancel out to 2, and oh happy day, I just have to double pi. 3.14 times 2 is 6.28, and we have centimeters. And it's just centimeters because we're finding the length of that little curve right there, that arc. And it is a fraction of the diameter. Now let's talk about the area. If I were to find the area of the entire piece of pie there. Okay, well, what is it? It's a fraction of pi r squared. Well, what is the fraction? Well, once again, it's 60 3/60ths. So we already know what that reduces to, 1/6. So this area of this sector is going to be, not the area of the arc. Oh, brother. I'm having 2 mistakes today. The area of the sector. Okay. We did the length of the arc. The whole piece of pie is called the sector. I apologize. All right. So the area is going to be 1/6 of pi r squared, the area of the whole circle. Okay. Let's go ahead and fill this in. So I've got 1/6 of 3.14. And what is my radius squared? 36. And so now I've got 1/6 of 36, so we can cancel out that to 6/1. And now my answer is going to be pi times 6. 6 times 4 is 24, carry 2, 8, 18, decimal point. And my area of just that sector is 18.84, and it's square centimeters because it is area. Okay. Fraction of the complete circumference for the arc, fraction of the complete area, pi r squared, for the sector. Okay, let's go to the homework now. Let's go to number 17, and I'm going to just double check right here on number 17 and see what we're going to use for pi. We, on number 17, are going to use 3.14. Okay. So for number 17, we are finding the area, and I didn't leave myself any room here. We'll come back to number 18 in a little bit. Let me move 18 down. 18 is going to be the perimeter of the figure. All right, let's go ahead and start with, in 18, we're going to use 3.142. Okay, all right, now, we want the area of this whole shape. Okay, well, let's first find the area of the rectangle. Okay, well, this is, the width is 3. What is the length right here? What do I look for? I look for the diameter of the circle, because that's the same thing as the length of this straight side here. And so it's going to be the radius times 2. The diameter is 6, so this side right here is 6. Okay, now, what is 3 times 6? Well, 3 times 6 is 18, so the area of this rectangle is 18. Now let's find the area of the semicircle. What fraction of a circle is a semicircle? It's 1/2. Okay, so let's go ahead and do it's going to be pi d divided by 2. The area of the semicircle is going to be, no, it's not. Okay. Y'all probably wondering what time this is. It's only 7 o'clock, and oh no, it's 8 o'clock at night. I am really struggling here. It's pi r squared divided by 2. Okay, all right. Sorry about that, guys. We're gonna get through this. Pi r squared divided by 2. Now let's go ahead and see what that is. Pi is 3.14. My radius is 3. And 3 is going to be squared to 9, and I'm going to divide by 2. Oh, joy. I've got another odd number here. So what I'm going to do is I'm going to go ahead and multiply 3.14 times 9. You can go ahead and do that on your paper, and we'll see what we get. 9 times 4 is 36. 9, 10, 12. Okay. I'm getting 288.26. And what are we going to do with that? Divided by 2. I didn't forget this time. Yes. Okay, so I am going to go ahead and divide that by 2. Well, dividing that by 2 is pretty easy. Half of 28 is 14. Half of 26 is 13. So 14.13 is my area of the semicircle, pi r squared divided by 2. Okay, I'm going to erase my computation here because I've got so much on the board going on. So what I'm going to do now is I'm going to take the area of that semicircle, and add to it 18. 18. Okay, so I've got 0.13, 32.13, and I did not write the units down, and the units are in centimeters. Okay, in centimeters. I know what's going on. Y'all know what's going on today? My middle son, David, and I told y'all, but he works at Mahoney's, they're having a baby right now. And it's Corona time, so I can't be at the hospital. And so I'm a little distracted. So I guess I can blame it on that. I don't like to make excuses for things, but I just realized, you know, I'm probably a little distracted by that. Okay, I'll let you know how it goes tomorrow. All right, now perimeter. Let's find the perimeter. I'm in the glare zone here, but let's find the perimeter of this figure, okay? Now, to find the perimeter, I'm going to add up the 3 straight sides first. I've got a 3, I've got a 6, and I've got another 3 down here. So we know what those are. Now, am I going to add the dashed line as my perimeter? No. Okay, so what am I going to add to that now? I'm going to add the arc length. I've got to find, like I'm putting a fence, okay? It's a curved part of my fence out here. Now, how do I find that? Well, it's pi d, it's the circumference of that circle, but it's only a half circle, so I'm going to divide by 2. Now, let's go ahead and fill it in. Pi is 3.14. Careful, my diameter is 3 times 2, 6, but I'm dividing all that by 2. Can you see through the glare? Sorry, guys. 6 over 2 is 3 over 1. Let's go ahead and find the arc length of that semicircle. That's going to be, what is that? Can I do that in my head? No, I better not. I don't trust myself. 3.14 times 3. 12. 9.42. Okay. Are you getting 9.42? I am. 9.42 for pi d divided by 2. Now what am I going to do? I'm going to add 9.42 over here. Now line up that decimal point, people. Line up that decimal point. 3, 6, and 3 are whole numbers. So be careful there. So to the right of the decimal point, these are all zeros here. To the right of the decimal point, I have a 0.42. Now let's add up our whole numbers. 6 plus 3 is 9. 9 plus 9 is 18, 19, I'm getting 21.42. Can you see that too? 21.42, and my units this time are in centimeters squared. Centimeters squared, okay? So for perimeter, pi d divided by 2. For my area, pi r squared divided by 2. Very simple. Okay, now last thing, let's go to number 10 and number 11. Number 10 and number 11. Now I think for these, we're going to leave pi in the answer for number 11. For number 11 and in number 10. Okay, now we are told in this drawing right here, I've added a couple extra things in here. And hold on, let me check, is 12, do I have, no, there's no units. There's no centimeters or anything. Okay, now, let's see. This is 60 degrees. Central angle ACB is 60 degrees. They tell me my radius is 12, and they're asking me in problem number 10, what is the area of sector, the area of the sector, like a piece of pie, BCD, okay? BCD. So they're asking me for the area of that sector. Well, in order to know the area of a sector, I've got to be able to know what this measurement for this angle is. But they gave me the 60 up here, but this is the sector I care about. Well, what if this is a diameter right through the center C? Can I find this angle? Well, I sure can, because 60 and this angle are supplementary. They add up to 180 degrees to half the circle. So what is 180 minus 60? 120 degrees. Now, let's find the area. The area is going to be equal to, and I should make that a little bit higher so we have room. The area is going to be equal to, what's my fraction? What fraction is this piece of the whole pie? Well, it's the angle, 120, over, what's a complete circle? 360. And then area of a circle is pi r squared. So let's go ahead and reduce this. 12 over 36 is what? It's 1/3. Now, they told me to leave pi in my answer. They told me to leave pi, and then my radius is 12. Ugh. And I'm going to have to take 12 and square it to 144. Okay, well, I'm almost there. So my answer is going to be, I'm going to go sideways here. I've got to divide 3 into 144. So let's go ahead and do that. I'm going to do it up here. 3 into 144. Let's all do that. I'm getting 48. Yay, it went evenly. So 1/3 of 144 is 48, and then I leave pi in the answer. And they don't give me any units, so if you just want to write units squared, you can, because it's area, okay? It is your fraction, 120 over 360 of pi r squared. That's all it is, okay? And you don't have to multiply this out. It says leave pi in the answer. Now let's go to number 11, last one. The degrees of major arc. How many degrees is major arc BAD? Remember, a major arc is greater than half a circle. So BAD goes all the way around here. Okay, how many degrees is that? Well, this is 60, and this other part here is half of the circle, so it's 180. And so in order to figure out the degrees, I'm going to take 180 and add the 60 to it. You see that? 60 plus 180 will take me all the way around. 60 plus 180, the number of degrees of that arc. And so what am I going to get here? I think it's 240 degrees. I'm going to write that over here. 240 degrees. Now, what is the length of major arc BAD? So what they want me to do is find a fraction of the complete circumference. Well, what fraction is that? Well, it's the number of degrees, 240, over the whole circle, 360. So I'm going to do 240 over 360, and we're talking about part of the circumference, so it's 240 over 360 times pi d. Well, what is d? What is my diameter? It's going to be 12, the radius times 2, it's going to be 24. Now, let's go ahead and cancel here. What is 24 over 36 going to give me? That reduces to 2/3. Now, I've got, so this arc is 2/3, all the way of the way around, it's 2/3, and it's 2/3 of pi d, 2/3 of the circumference. Now, let's go ahead and cancel. I've got 24 over 3 is 8 over 1, and I'm left with 2 times 8. I'm going to go over here. I should go a little lower. Over here is 16. 16. It's hard to write. My pen is getting funky. 16 pi. And this is just like circumference, so this would just be units. It's not area, it's not squared. It's 16 pi units. Okay. That was a lot today, guys. That was a lot. Now, did you get all that? Did you get all that? Okay. So to find an arc length, you take the fraction of the circumference. To find the area of the sector, the piece of pie, you take the fraction of pi r squared. Okay. And the semicircle is the fraction's always 1/2. So that's it. Now, you haven't seen any omissions up here, have you? Well, I knew I had so much work to put up here, I thought I'd save them to the very end. So here are our omissions today. We're going to omit number 1, number 4, number 5 from page 1, number 12, number 15, number 22, and I'm out of room here, and last but not least, number 23. Okay, let's review those one more time. 1, 4, 5, 12, 15, 22, and 23. And then we've done 17, 18, 10, and 11. Okay, now this is due on Thursday. So come see me at Zoom at 1 or 2, and I'd love to help you. And things are getting a little bit more difficult now with all these more advanced equations and sectors and arc lengths and distributed property and scale factor and all these big things we're doing right now. So please let me help you. You can also chat with me if you have a question, but I'll see you at 1 or 2, and if not, I'll be teaching you some more tomorrow. So have a great Wednesday, and I will talk to you soon. Bye-bye.